remember that if you are multiplying a matrix. That doesn't write. Here we go. And let's say you've got 2, -1, 3, and 8. You're multiplying it by, we'll say 4, 7, -3, and -2. Okay, so if we're multiplying, okay, we are going to have to check to make sure the inner dimension matches, which it does. So that means we can multiply, and that means our solution is going to be the outermost, which is a 2 by 2. Now, what makes this difficult is you're not just multiplying one number to fill in that blank. You've got to do the row by the column based on its location. So this location is row 1, column 1. So I'm multiplying row 1, column 1. So you're multiplying the first one by the first one. So 2 times 4 plus the second one times the second one. Okay, so then you do your multiplication. 2 times 4 is 8. -1 times -3 is +3. 8 plus 3 is 11. Does that make sense? Okay, then for the next one, that's row 1, column 2. So row 1, column 2. So you've got 2 times 7 plus -1 times -2. Okay, so you do your multiplication first. So we've got 14 plus, that's +2, which is 16. Okay, we do it again. Whoops, nope. Just need to change colors. Okay, we do it again. That's on the bottom row. So we're multiplying bottom row by first column. So it's 3 times 4 plus 8 times -3. 3 times 4 is 12. 8 times -3, is that -24? Okay, you add that together. So that's going to give you -12. Is it making sense? Yeah, you got it now. It's easier like when you can see me do it, obviously, than when you're doing it on your own. But you just have to remember to do the location. So this is bottom row, second column. So 3 times 7 plus 8 times -2, multiply. That's 21 plus -16. What's that going to be? Is that 4? 5, +5. Let me double check because I really don't know. Yep, +5. And so that's your answer. Okay. All right. So that's just kind of a review for us going back over matrix. You will see those on your chapter test. So we can keep going over them again and again if we need to make sure you guys are understanding. All right, today though, we are skipping ahead quite a bit and moving to lesson 4-3. Lesson 4-3 is on page 65. So everybody go to page 65. My virtual people, we are on page 65. So page 65 of your textbook. We are going to talk about absolute value equations and graphing them. All right, so our targets for today and what we are trying to accomplish is we want to identify the effects on the graph of replacing the f of x plus k, k times f of x, f of k of x, and f of x plus k. All that probably doesn't mean anything to you, but basically what it means is that we're going to be shifting this graph up or down, left or right. Okay, so that's what we're going to be working on. And then also it says find the value of k given these graphs. Okay, so before we even get too far on this lesson, I want to just go ahead and give you the formula, okay? So somewhere in the column on your page, write this. This is like what all of this whole lesson is about, okay? So we're going to have y equals. Now, typically we're used to seeing y equals mx plus b, but this is not linear. This is absolute value. It's a form of a linear graph, but it has its own special characteristics. So we've got a, that is a absolute value line is what that is, okay? X minus h plus k. Now, each of those has a role, okay, and what it's going to do and how it's going to transform this graph. Now, they're assuming that you guys used this absolute value back in Algebra 1, which is probably not the case. I don't hardly ever get to it with my Algebra 1 classes, but if you did, okay, what you're doing is you're looking at the linear parent function. If it's y equals the absolute value of x, okay, so it's going to go through 1, 1, just like the linear parent does. 2, 2, 3, 3, 4, 4. So it's got all of those points. Because if I plug in 1, what's the absolute value of 1? 1, that's how we got 1, 1. If I plug in 2, what's the absolute value of 2? 2. Okay, so the graph is going just like a linear graph from the origin. However, if I were to plug in -1, what's the absolute value of -1? Positive, so it would actually end up going this way. So if it was linear, it would keep going in this direction. But that's not what's happening, because with absolute value, you don't have any negatives. And this down here is in negative, or just negative number. Why do I keep doing that? Negative x, negative y, okay? But what we're looking for is we want all of those y numbers to be positive, because they're going to be the result of the absolute value. So we're actually going to just go this way. So we end up with a V graph. All absolute value graphs are V graphs. The parent function, which is this one, it says the absolute value function, f of x, which is just a different way to say y, is the parent function of the absolute value function. Recall that the parent function is the most basic function of a particular type. Transformations may be performed on the parent function to provide a new function. Okay, so your parent function is right there. It's going through 1, 1, 2, 2, 3, 3, and then it's also going to go through the negative. So if you drew this on a graph paper, so it's perfect, I'm going to do that real quick because it is very important that you understand what it looks like. Okay, so there is our linear parent function. It's going up 1 over 1, up 1 over 1, and then on this side, it's just the reflection of that. Okay, it's keeping everything positive. No y values are negative. There are no negative y values because it is the absolute value equation. So this is the parent function. Now, what we're going to be doing in this lesson is we're going to be taking that parent function, we're going to be moving it up, moving it down, moving it left, moving it right, all kinds of things. Well, that is all the result of that equation that I just told you to write down. So that's what we're going to do, is we're going to figure out who does what. A has a job, the one that's in front. H has a job, and K has a job. So that's what we're going to figure out today, who does what. So if we look at the first one, you can see that we've got our absolute value equation. So this up until the +1 is the parent function. So that's not changing. The only thing that we're doing is we're putting +1, okay? So if we think about that in terms of a table, okay? If I have my parent function table, we've already said that it's 0, 0, 1, 1, 2, 2, 3, 3. Okay, so that would be the original parent function. Well, what they're doing is they're saying, okay, well, whatever you get here, your absolute value, you're going to add 1 to that. So if we plug in 0, we get 0. What's 0 plus 1? It's going to be 1. Okay. Then if we plug in 1, what's the absolute value of 1? 1. 1 plus 1 is 2. So each of your y values are going to increase 1 time. So what that's going to do is it's going to take that parent function and shift it up 1 place. So your absolute value graph just shifts up. +1, it just shifts up 1 place. Now, I think they wanted you to draw the parent function on here too. I'm going to just sketch that with this little pen. So I'm just putting the dots there at the origin and then moving it up. So you can see we didn't change the width. We didn't change anything about this graph. We just simply went up 1 place. Just took the whole V and shifted up 1. So that tells me that what is this K going to be? Okay, well, we're not sure. So let's try this one then. So if we look at this one, that one says -2. So if this one said +1 and we went up 1, what do you think the -2 is going to do to our parent function graph? David, what do you think? Do you even have a guess? What you confused about? Okay, well, look, the +1, what did it do to our parent function? David, put your phone down and pay attention. I'm trying so hard to teach this to y'all. Up 1, right? Whole graph, up 1. +1, the whole graph went up 1. Not hard. Whole graph, up 1, +1. What's going to happen when we do -2? Down 2. That's it. Okay. So instead of it being at the origin right here, we're going down 2. That's it. Well, that's because of the table of the parent function. But this one is going to allow us to have some negatives, because when you shift everyone down 2, then you will have some negatives. I can see, Katie, how that would be confusing. This one will, though, just because of the shift. So here we go again. K. That's what we just dealt with. If it's +1, it goes up 1. If it's +100, it goes up 100. If it's -2, it goes down 2. If it's -10, it goes down 10. So what is K's job? What's the shift? What directions did we go? We went down and up. So it's the direction of the shift, either up or down. We call that the vertical shift because you're moving vertically. So anytime you see a plus behind the absolute value or a minus behind the absolute value, not inside the bars. This has got to be outside of the bars. Okay, so for example, if I just put plus 6, I am adding a vertical shift. I'm taking that graph and I'm shifting it which direction? Up 6 units. That's it. Make sense? If I want to go down, I put minus 4. So I'm going down 4. So if we had like a manipulative and I could give you this little V, okay, and you had this like paper V on your graph, you would literally just be sliding up and sliding down, depending on how many it tells you, minus how many or plus how many. Make sense? Cool, we've got K. All right, so we've got K. So now we are going to look at what happens if something is in front. Okay, this one has a 3 in front. So how does that affect our graph? Well, I am going to just set us up a table because I feel like maybe this might make it a little easier for y'all. We want it to be easy. So I just picked us some negative numbers, a 0, and some positive numbers. Now, to get the answer, we're just going to plug in. We're going to go old school just like we used to do in Algebra 1. So all I did was plug in x. Everybody see that? This -2 is the x. I'm plugging it in for x. Everybody okay with that? What's the absolute value of -2? 2. What's 2 times 3? So this is 6. So your ordered pair is -2, 6. This time I'm plugging in -1. What's the absolute value of -1? +1. Outside of the absolute values, those are gone now. What's 3 times 1? 3. Okay, plug in 0. What's the absolute value of 0? 0. What's 3 times 0? 0. We plug in 1. What's the absolute value of 1? 1. 3 times 1 is 3. Plug in 2. What's the absolute value of 2? 3 times 2 is 6. Okay, now let's plot those points. So we've got -2, +6. That's going to be off of our chart just a little bit, but we can just put a little dot above. Okay, -1, 3, 0, 0, 1, 3, 2, 6. What happened to this graph? It what? It did go off the chart, you're right. What happened to it compared to the parent function? Let me put the parent function dots up there. So compared to the red dots, what do you see? That's right. The lines got steeper. You see that? The V is now skinnier, more narrow. Okay. So our initial V was here, and then we tightened it up. Okay. So it got, you know, skinnier, it got more narrow. Well, that's because of the 3 in front. So the 3 in front caused its arms to be steeper, which is what happens with slopes, okay? If you're comparing like a slope, and you've got a slope of 2 and a slope of 4, which one's going to be steeper? 4, okay? So like here's your 2, here's your 4. Think about the slopes when you go skiing, okay? When you go skiing in slopes, they label them like bunny slope. That one's like the flat. Then you have like a level 1, level 2, level 4, and then you have like the blacks or whatever, okay? So the higher the number, the steeper the slopes. That's the same thing here, okay? So if I were to put a 5 in front of there, it's going to be steeper. A 6, it's going to be steeper. However, if I put like a fraction, like 1/2, okay, that's going to be more like a bunny slope. Okay, your parent function has a slope of 1. So here's your 1. That is just your normal everyday slope. If the number is greater than 1, it becomes steeper. If the number is less than 1, but greater than 0, so it had to be a fraction, 1/2, 3/4, 1/4. Okay, any of those numbers are going to make it less steep. That's like a bunny slope. Okay, so that's the same thing with this. Higher numbers, steeper, more narrow. Smaller numbers make it wider. So if we were to have 1/2, we would end up being, let me just show you 1/2. So 1/2 would actually be the green one. And to get those dots, I'm literally using slope, just like you would for a line. Rise 1, run 2, 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 okay? So that's because your slope is 1/2. So you can see it is wider than the parent function, okay? Numbers that are greater than 1 make it steep. Numbers that are less than 1, greater than 0, make it wide. Now, what happens if we have a negative? Okay, so if we have a negative in front, what do you think that's going to do? Just a guess. Exactly right, Katie. It's going to go down, okay? Right now, everything's positive, positive, positive. We're reaching for the sky. We're positive. But if you put a negative in front of it, boom, we're going down, okay? So you can also see that on the table. So if I were to make a table for this, same table that I made before, -2, -1, 0, 1, and 2. And I plug in those x values, okay? So this time we've got q of x equals negative, and then in absolute value, -2. So what's the absolute value of -2? +2. But when you bring down that +2, you also have to bring down that negative. So then your answer is going to be -2. If you do it again, q of x equals -1. What's the absolute value of -1? 1. And you bring down that negative sign. So that's -1. 0 is going to be 0. There's no such thing as -0. 1 will be -1, and 2 will be -2. So this time we have all negative y values. So when you graph that, you've got your 0, 0, 1, -1, 2, my pen's being weird. 2, -2, -1, -1, -2, -2. So you can see this time it's going down. So A, let's talk about A. We know that K is our vertical shift. What does A do? What's the 3 make it? More narrow. And the half makes it wider. So A determines the width based off slope. And then put a star and say if negative. The graph reflects. Okay, so it's positive, stays positive, but if it's negative, it's going to reflect it over the x-axis. Okay, it can make it steeper and reflect it. So if you had like a -2 in front, that 2 itself is going to make it steeper. The negative is going to reflect it. Okay? All right, so now the only one that we don't have is H. What do y'all think H does? Y'all are a tough crowd today. Sleepy? Well, I mean, yeah. I mean, we've already talked about up and down. We've talked about the width. So what would be left? Do what? Like we've gone up and down. We've exactly side to side. That's the only other thing that's left is to go side to side. So H is going to be our horizontal shift. It's not rocket science. Like don't make it hard. We'll go ahead and add that one in. So we can go ahead and know, we already know what it is. This one is our horizontal shift, which is left and right. Now, this one, however, is the one that's a little bit tricky because when you look at it, if we look at this, we're looking at something that is inside the absolute value. Okay, so first of all, your horizontal shift will always be inside the bars. So inside the bars, if you've got a plus or a minus inside the bars, you're going left or right. Okay. Now on this one, this -3 right here, you know you're going to be going either left or right. Okay. So if you're like me and you see a negative, I automatically think left because I would think plus would be positive, but it's actually the opposite. Okay. So if you've got a minus sign right there, you're actually going to go to the right. So originally we were at the origin, right? Our parent function's here at the origin, 1, 1, 2, 2. That's our parent function. So what we're doing is if we had a piece of paper and then we could physically move it, we are shifting it to the right 3 units. So 1, 2, 3. The whole thing goes over 3. This black dot goes over 3. 1, 2, 3. And then we've got our new absolute value equation. So the slope, the steepness didn't change. We didn't go up or down. We literally just took that graph and we shifted it right 3 units. So make sure you know that if you want to go right, you need a minus sign. So what's the plus sign going to do? Gonna make it go left. So let's look at this one. We look at number 3. We've got plus 2. We were originally at the origin. Stair-stepping our way up. That's the parent function. But if we have a plus 2, we're going left 2. So 1, 2. That is your vertex. That's what we call that point. And then once you've got your vertex, you can just put your dots. Hey, oh, can we teach him those? Does it make everything kind of blurry and glassy? See, because I have this one. I don't think so either. When he said we had to wear both, I was like, no, I'm not doing that. But this like makes me have like a reflector, and I can't deal with the reflection. So I don't know if this one's just cheap or what. No, you can't see that. You might have the coronavirus. I know. I trust you. And even if you're quarantined, I'm quarantined. Oh, this one's much better. This one's much better. Yeah, if he would let us wear those, that would be awesome. Especially if we're up at the front of the room, you know? Yeah. Okay. So we've learned all the parts. A is the width based off the slope. Steeper, less steep. If it's negative, it flips it over. Okay? The horizontal shift is our left or right. Okay? The K is your vertical shift, up or down. All right? So let's see if you guys can string that together. Go with me to page 72. Go with me to page 72 and look at number 17. The instructions say to graph. We're not actually going to graph. We're just going to look at these. So page 72. Let me get there too for my virtual people. Gosh, I can't wait till everyone's home. I want you all in this classroom. Yeah, you're definitely not going to like it because I'm going to be way stricter. It's going to have to be. Like, there's no reason that y'all need your laptops, your cell phones, all of that. I'm going to be so much stricter. Y'all are going to be like a book, paper. Do what? Yeah, you'll need to bring them, but it's just going to be more. Yeah, you have your own book, though, so. Do what? Yeah. Okay, let's look at A. Okay, is there anything in front of this one? No, so there's no change in width. The width is still the same as the parent function. Then you have this plus 3. What's the plus 3 do? Left, how many units? 3 units. What's the minus 1 do? Down 1. That's what's going to happen to that graph. Okay, so we are going to go left 3, down 1. Now this one, okay, remember each time we're looking, we're looking at this formula to figure out what is happening. Okay, so this 1/3, is that A, H, or K? That's A, which controls the width. So is this going to be more narrow or is this going to be wider than the parent function? It's going to be wider because it's a fraction. Okay, it's like a bunny slope. So this one is wider than, I'm going to put PF for parent function. So wider than the parent function. Then what is plus 2, H or K? It's K because it's on the outside, okay? And K tells us if it goes up or down. So what's that going to do? It goes up 2. That's your transformation. Then we look at C. You do C and D by yourself. You do C and D by yourself. What's the -2 make it do? It makes it more narrow. Okay, so more narrow. But it also does what? What's the negative do? Reflects it. Okay, reflects over the x-axis. So it is more narrow. You're correct, because the 2 is greater than 1. So because 2 is greater than 1, it's more narrow. But the negative is what reflects it over the x-axis. Okay, then what does the -1 inside the bars make it do? Good, right 1. And what's the -1 outside the bars make it do? Down 1. You getting it? You figuring out who does what? Okay, what about D? What happens on D? What's the 5 do? More narrow. More narrow. What does the -1? Right 1. Right 1. And yes, down 4. Now, we're not physically graphing these yet, but we're going to. Okay, so this is where we're going to stop with this lesson. Your homework is to do exactly what we just did. You're repeating that with your own problems. Your problems are on page 70. You can do 16. It's asking for what's happening on 16. And then on 18, where it says graph, don't like scratch that out crazily, but I want you to describe the transformation. You don't have to actually graph it out yet, but on those problems, those are the ones I want you to do exactly what we just did. So I'm going to circle them for you. So you're doing number 16 because that's what the whole thing's telling you to do. Describe. Okay, you're describing the graph and its transformation. And then for 18, what I want you to do today is describe. You have to do 16 and 18. Remember, 18 has 4, though. So that's what you're doing. Those 5 things, 5 descriptions. Send me your notes. Send me your homework. Put your names on it. We will keep working in this lesson. We are not done with this lesson. So that will change our module, but that's not that big of a deal. Okay? Charlie, you got any questions?
No, ma'am.
All righty. See you tomorrow.
Oh, yeah, that's right. I actually have to come to school tomorrow.
That's right. Me too.